Right, so welcome to our last before last, right? So pre-ultimate lecture. Today we talk about computer vision. Right, so what's involved in computer vision? How do we define it? And of course, the challenges and also the big wins from the last 10, 15 years. A lot of improvement, a lot of actually fantastic, I should say, progress has been made. Things which was basically sci-fi maybe 50 years ago is now basically reality. Right. So basically anything that enables us to, robot cars, any kind of object recognition, it's really been pretty amazing. So how do we define, of course? So what's a vision in general, right? It's a perceptual channel, right? That accepts some stimulus, right? And we record something about the world, right? Also, we have two element mentions here. Actually, I should probably I'll open up in GitHub so we can add some changes. Right. So there's what kind of vision? The kind of vision we use, humans, right? We look at the light channel, right? We build some image, some representation, but it's basically passive, right? So what's the alternative to passive? Active, right? Of course. Yeah. So, what can you think of any examples of active vision?
Radar, maybe.
Yeah, radar would be a way of, or lidar, right? Yeah, radar, of course, laser. Some sort of you send out response, but in a let's say not human life, but in other life. Do you know who using active sensing, active vision?
If you build a robot.
Yeah, robots too. Yeah, but I'm talking about the natural world. Yeah, like the obvious example.
That's using.
Yeah, Batman or Batman. Batman. Right. Batman also might be using it, right? But that's for sure.
They're also using it.
You mean?
Aren't they also using it?
Who's using it?
Like we.
Humans.
We're doing send out, but we don't send out. Basically, we're not using sort of like sensing. We're not bouncing back signals. We take it as this.
Maybe visual ones, yeah.
Yeah, touch based would be, yeah, it's not really, I mean, it's similar concept, it's not really our vision, right? It's more touch based, like if you're blind, right? Yeah. And of course, if you are doing some sort of cybernetic implants, into your body, you could do some sort of things like they have magnetic implant, right? I know hear of people doing this, right? They get the sixth sense. They implant something, a magnet, right? And they sort of get this amazing ability to sense direction. It's kind of well, I don't know if it's cool, but it's interesting, right? I don't know anything personally, but I've seen this research of people who do this. So. Oh no, I get my passport. Okay, good. All right, now, okay. Let's authenticate. So what kind of features do we get out of our visual sense? For senses, basically, I guess it's sort of like a color information, right? What kind of colors we get? You think of it as pixel by pixel-based vision, right? That's one way of looking at the vision. Two by two. All right. Later. Okay. Can't see anything. Actually, it would go like this. All right. Maybe you can move. Okay. Yeah, that's better. Where's my post-space? Let's open up a post-space. So one thing you should remember about images is that nothing is as it seems, right? You probably heard lots of all kinds of cool illusions, right? Optical illusions, right? Optical sensors are notoriously bad well, they are tend to, they are, how should I say, biased towards some set of illusions, right? Let me see some optical illusions, Right, let's take a look at some of the famous ones. Let's see, right? Movement. What the heck is this guy? Oh, there's something else happening, right? Right, the shapes, right? This one is kind of pretty well known, right? Right. So what's going on here? You know this one? All right. Yeah. So. Right. So which one is darker? Right.
Well, it's definitely A.
Yeah, A looks darker, right? Yep.
Oh, it is.
But it's not.
What?
Yeah. That's the evil thing. Right. So A, this shape, same as B. How? You do pixel comparison, right?
Let's do, yes.
Yeah, let's do that, right? I'll get to, can I install pixel, like whatever? Pixel, what do you call pixel? What do you call these plugins? Pixel color.
Actually, I think you could use this console for that, can't you?
Yeah, we can check that because it's really good.
You can use paint and select the color from your screen.
Oh, yeah?
Yeah.
Okay, so control R, right? I'll get this. I'll open the new app. I'll click here, right? So control R. I think I can copy this, right?
It doesn't even need to be in paint. You just go to paint,
Yeah.
take the color picker, and you can do it from another screen too.
Okay, so you paint. Okay.
I think you should print it out and then we can check it.
Okay, so, all right. So, color picker, right?
Yes.
Where is it?
To the right. Where you change the color.
This one? No.
No, more to the right.
No. This one?
Yes.
Yeah. Is it close?
Yes.
Okay. How do I
Customized, I think.
customize?
Yes.
All right, on.
Add color.
Maybe it doesn't.
Can you just crop A square and B square?
Yeah, okay, let's try it. That's good. That's good idea. Okay, let's do that. Yeah. All right. So I'm gonna answer this, right? Let's see this. Because don't trust, of course, don't trust me. Don't trust. What's the name? Wikipedia. So it's crop things. All right. Okay. Can you check over here, maybe?
No.
No.
No, but you can move it.
Control X, right? Control X. Oh, there you go. Well, come on. Too smooth.
Maybe you can use arrows for this one.
Okay.
Oh,
What?
that's
Wow,
Yeah.
amazing.
Yeah. Don't trust yourself, right? I mean, so it's of course why is this the case? Because of course the contrasts, right? You have the shading thing going on, right? It's like, how could that be, right? Because if you contrast things, right? The psychological principle, right? You have this whiter stuff here, right? You have darker things here, right? So of course the trick here is kind of like you don't notice this gets these are really dark and these are much lighter, right? So these, right? Identical squares actually turn out to be, they look to our eyes look, different. So we crop one more crop. So here, right? Oops, no, come on, where's my view? I don't know how to crop it. Control Z. Yeah, okay. Selection. Do one more. Go back. Control X, right? You have GBD before like this. Yes, I think illusion. Come on. Okay, like this. Maybe bigger.
I think you can use like arrows, can't you?
Yeah. Okay, of course you see it. Yeah. So of course. Yeah. Okay. Now, so one of the more we will move one of these if you have time, but let's keep going, right? So Five, right? Let me do this one's vision. Let me add this illusion here.
That's why it's called.
Of course, we've seen all those wiggly line illusions as well, right? Yeah, there we go. All right. So of course, ice costs money, meaning energy, right? We have to eat, right? So, but of course, it's critical, right? If you're looking for tigers, right? Right? You need your eyes, right? So again, we did mention actually passive sensing, right? So feature extraction, right? Well, we want to know what he's looking at. His computer, right? He's looking letters. There are all kinds of different levels of features, right? It's like big object extraction, a thermos or a mouse, right? You see a phone, right? Or also smaller, pixel by pixel extraction as well, right? So again, the issue is handling abilities, like the core problems, right? Reconstruction, right? So you have images, right? And you want to create a model of this world, right? Another one, of course, is recognition. Is the model or not, right? Is it, but what is it, right? So that's where we get a lot of progress, right? So a lot of things have changed, right? So again, images, right, can distort through this appearance of objects. Railway tracks, railway train tracks. I figured to convert distance. Okay, let me give you a picture, right? So small objects like a hand can block much larger objects, right? You've seen all these pictures of people, on a leaning tower of pizza, right? They standing next, all these little tricks, right? Let me give you some images, right? Illusion. Go back. Illusion. Leaning tower of pizza. Right? This is the pizza. How does it called? Pizza 2S? I forget how you spell it.
No, I think it was correct.
That's correct, yeah? Yeah. Something like that, right? Yeah, then other ones support Pinterest, of course, right? Leading tower inclusion, right? Yeah, right. Once you see some people doing things, right? Not see anybody. So there's some two German churches are annoyed that pizza is actually famous. They say, okay, there's divorce. They say there's living more, actually, apparently. I don't know. I mean, I'm sure we could do it too, right? We could do the most force building, right? I mean, I'm sure you've seen the. Oh yeah, so let's go to this one. Yeah, so this is extremely common, right? Of course.
Arto also has house that looks tilted
Yeah.
center.
Try to move it, of course. Here. Distortion. So object, of course, right? So distance, right? Distance. Distortion. What they do here? Wrong picture. Wrong story. Copy paste it more. Oh, there you go. So these are sort of kind of fun party things, but one second. Oh, let me see. Wrong approach. No, it looks okay to me. Maybe here. Oh, there we go, I guess. Yeah. No, Okay, right. So, 3 or more, of course, right? One is looks smaller than the, yeah, right? Crystals, right? Who is closer, right? Of course, look bigger, of course, right? So it's one of the challenges, of course, identifying the distance, right? So we have to. So how do we build a camera to capture this, actually, right? So we won't talk too much about this, but of course, the classical way was use something called a pinhole camera, right? Let me show you what it looks like. Pinhole camera, right? Obscure. All right, something like this. All right. So you have a projector, you have something outside, right? And you have this projection inside. You probably also remember from biology that our eyes also have the same thing, right? We are seeing, you're actually getting image backward, upside down. You know that, right? So, as a kind of interesting example, there have been experiments in people who have they get these really weird glasses which turn the images the other way around. So everything's upside down at the beginning. And after like, I don't know, a couple of days, they start seeing this world as as they want it to be, basically. Back to normal, even though the glasses are wrong. Right?
Can they get stuck in that?
Well, I think that's really. I will not. It's like mind hacking. I will not want to do it myself. I think it's horrible headaches. I don't really. I know. I mean, it's a scary experiment, right? Because what happens is then you take off the glasses and then the world's upside down, right? And that's the thing. That's really, really, really not fun. I don't think, right? Camera. Let me see.
Very well.
Right. So, of course, again, another thing, those who do it, and then if you guys do photography, like, of course, we all do photography because we have phones now, right? Is anybody serious about photography? Not really. Not serious, not that serious. Okay, but basically, right, of course, I'm also not very serious, but still, some issues are, of course, the motion blur, right? If you move things too quickly, right? That's another issue, right? How to capture this blur, right? And also the time window, right? So again, you see some images of early color photography, right? So let me see. This is probably famous, of course. The guy is well.
Saulesbrīlis neesmu atstājis. Sēdēju tur, un man tur bija saule.
Let me get to early color photography. This guy here, right? Sergei Kokosin-Korsky, right? He was one of the pioneers of color photography, right? A lot of cool pictures from famous ones. So what he did, of course, first of all, you get to color, right? Of course, you have to take 3 pictures, right? And then combine them. 3 channels. So you use 3 filters, right? What I see someone, I want to show you is the blur, right? Sometimes, right? This is how we combine pictures. But if you see some pictures with water, right? You'll see it show. We did it all for like 120 years. Oh, this picture here, right? This guy who spent all his life on being the boat, we call Rams, ferry people across. I guess he had 2 arms. He was like 80 something, right? So, but as you can see, so there's blur, of course, here. Why? Because, of course, he had 3 pictures, and of course, water was not standing still, of course. Water was moving. Exposures in early photography were long, right? So, it took the pictures, things moved, right, of course, so, picture changed, right? An issue, of course. All right. Where's the picture? Again, I can't. Oh, stop with this. I guess I can't. Nothing's wrong. Let me see what's happening. I can't go for too much. Yes. All right, now. Yeah. All right. You can see here. There's another even better example. See, of course, that the pattern is moving, of course, right? There are the pictures. So you need to. Oh, I mean, this is I did it last time. Google people can visit our. So now, of course, I did it. Right. So it's there. So pinhole cameras. This is like early sort of a way of working, right? They have something called, they have small aperture. The window, the pin, right, it's small, right? So, you can increase the size of the aperture, right? But you add more light, of course, but you introduce multiple entry points of light. So this means you lose focus. So it's a downside, again, in cameras, right? So adjusting focus, of course, you move the lens, like or glasses do, right? So again, if you remember this from your biology, so I won't spend too much time, right? So all this has to be, of course, your sensor. So this is all talking about how to get data in. Again, garbage in, garbage out, basically, right? So here, if you have bad sensors, of course, right? So you have bad results. So one of the simplest features to get from image is, of course, color information, right? If you go to this guy Irfan, I don't know if this is Irfan. Yeah, it does. Okay, oh, it does. No, I did portable. Oh, again, it's down, right? So I'll do download. Oh, we can. Oh, this is a really oldie. Oh, we can. It's down. Yeah, let's see. Yeah, let's do it fun. Yeah, I can do it. Users, right. Okay, so that is not summarized, yes, important. Okay, but yeah, the thing is, most basic image applications have ability to look at the channel information, at the color information of all this, right? So people who are working there are not too annoyed with us. Right? So color channels, like if you're using Photoshop or GIMP or any other normal, relatively advanced software, right? You can get the color Okrita. No, that's Copilot, right? So what else do we have here as an image? Because Paint, it's pretty sure it does not have. Maybe it has now, right? Again, the color channel. So basically, the important we know color that we are looking at, right? And a lot is actually made up of multiple channels. So basically here we can use. It turns out we only need 3 channels to basically show all the human light, basically all the human color, right? So this principle actually I think goes back like 19th century actually. You see colors? Yeah, welcome back. So of course, what is light? Right, light of course is just a bunch of wavelengths, right? It's not light. There's a big fight in 18th century. Is light a particle or is it a wave?
Both.
Yes, you know the answer. Yeah.
They were the
He's smart. He's smart. He reads books. No?
Physics, natural science. Yes, sir.
You did physics, right?
Yeah. We all.
Okay, you all. Some of you remember, some of you forget. Alright, so, okay, I don't know, that came out weird. Okay, so, but the idea is, of course, that or any color can be created by mixing appropriate colors of 3 primary colors, red RGB, red, green, blue, right? This is not the only approach, but there are other color scales, right? There's cyan, yellow, magenta, no, CYM, right? CYM, right? No, let's see. Yellow, magenta, and something else, right? Cyan, yellow, magenta, right? So, so you can model any color with these 3 channels, right? So, you model intensity, right, and you get back the actual color, basically, right? So so this would be a feature, right? Get the color of something, right? So simple features, right? So one thing you want to do, of course, is maybe you want to simplify the representation. Maybe you're getting, 4K image. You don't really need the 4K, right? You want maybe only smaller, compressed image, right? So one of the issues is of scaling, right? Because if you do anything with machine learning for images, right, you'll notice that most algorithms work with small images, like the digit example, like 28 by 28, right? These days, some neural networks use like 300 by 300, right? You don't use 2K by 2K, not too often. Why? What's the reason for that?
There's a lot of pixels.
Yeah, it's a lot of pixels. So 2K by 2K is what? 4 million, right? 4 million. That's one. If it's single color, right? It's 1 million, but by 4 million bytes. But if you have three colors, right? There's like 12 million bytes for a single picture, right? Uncompressed, right? So you want, of course, maybe scale down, because it turns out you don't really need that big picture. What to do is useful. So okay, so things you want to do, basic stuff. Edges, right? Where is change, right? And these are things. It's like a foundational operation, right? So it's not very smart, right? But it's actually going to be tricky, right? Where one image ends and where other one starts, right? One part, one object, like especially the colors are similar, right? Red, I don't know if you're bleeding, right? Where the stand, right? So texture, right? Do you have stripes on it? You have stripes or stars and stripes on your shirt, right? Optical flow, right? How actually more pixels between consecutive images, right? Segmentation, a huge field, meaning you want to divide your image into regions with common characteristics. If you follow this field, there is a library by Facebook called Segment Anything, right? Which is very good, like General Start. It's called Segment Anything. Let me give you a link to this. Maybe I'll mention this again. Link to Segment Anything library. I need to turn on my AI, so it can do it for me. Yeah, lady. It came out a couple of years ago, but it's not going to be updated. It's updated a couple months ago, literally. My favorite. Yeah, okay, segment anything. So let's see this is true. Yeah. So a new AI from Meta AI, of course, right? You can cut off any object. There you go, right? So very important. This is like core technology, right? So you want to get different courses, the dog, right, out, right? And of course, when you add it into video, of course, right? Of course, because what's video? Video is just a bunch of pictures, one after another, right? So, but you can do it in real time, you can do it in video, right? Now, let's see what you do is, I've done before data set. It's relatively, how often you use it, right? Let's see. The full data set, I think maybe have to the library, right? Right. You can see how it segments things, right? Shirt, face. Again, and of course, the idea, of course, it's agnostic, meaning it doesn't know what it is actually, right? It's not the term is not it does not determine what it is. That's for later part, right? You just get separate things, right? So pretty useful, right?
So this just tells that we can also live with like rainbow random colors.
Yeah, completely random colors. Right. So so it's 1 billion. That is an explorer, right? So could we upload here? Could it work right now? This 50K preview, right? So we want a full data set, right? You can choose the preview, but I think good Hugging Face is available there somewhere. Right? Yeah. See, I'll basically change original image, right? So it does a really good job, right? All these products, right? right? Individual features, right? Individual segments, right? Wires, right? Some of these are pretty hard, right? This like Japan or something? No, what is this? All right. To segment anything. Yeah. No, to do all I have to do, go to write locally. Oh, there you go, right. To do segment anything. Locally, I don't know. All right. So again, so edge operations are kind of basic. There's mid-level operations, you know, like segmentation. It's kind of it's a kind of mid-level operation, right? Now once you have these segments, you need to make sure you want to do what we call, of course, we call it classification. What the heck is it, right? So that's our next step, right? So next step, edges, textures, optical flow, and you get to classification. So there's two issues. First of all, this used to be extremely hard problem. Again, 15 years ago, this is still not solved, but now it's not, I would say solved, but it's a most cases are relatively, works pretty well, right? High accuracy has grown quite a bit. So the thing is, of course, if you want to determine just a single object in your image, but that's actually sort of the easy case, right? Usually, your image will have multiple objects, right? Have multiple people here. You want to say, who is everybody here, right? So as you probably seen this, there's a demonstration in a lobby, right? It does this real-time recognition. Do you guys know how it works? It's using OpenCV, basically it's a library in Python, right? Which gets you all the faces, right? And then it's passed to a sentiment analyzer. Each face is basically cropped and sent to a model which said, okay, is this a happy face or an unhappy face? It used to run like a month ago. I don't know if it's still running. I guess not. Of course, that's turned on, of course, right? So, again, something that is relatively hard, now it's extremely commonplace, right? I mean, I've seen quite a few bachelor's theses do something like that as image recognition, of course. But, so now the challenge is in these edge cases, meaning we have like a round, like a label here, maybe you want to recognize things like this, or individual buttons, maybe on a remote, things like that, right? So improvements will quite a bit. So we need to deal with the information. So how is it done? That's very, of course. So how would you do it? Well, we use CNN, right? So heavily using conventional neural networks. So incomes, right? Right. So the only challenge is to have sufficient data, right, to build your neural network with labels. So if you go to the let's get an example, hot dog or not hot dog, right? You probably see this video, right? Yeah, so that's what I've been talking. It's gonna use, it's like 3 minutes. Oh, it's 3 minutes. Okay, so you watch yourself. So that work, right? I don't want to watch your ads out. So, but yeah. And this actually is, you see this is from show Silicon Valley, right? But actually, that is the actual real web app. They built for the show, they built the app. Yeah. This is like 6 or 7 years ago, right? And so this guy who built it, he was not actually a full-time coder. He was actually, I think, was a journalist or producer. He had some interest. So he, of course, found the neural network. He didn't train it himself. And he just, threw it together into Android app. Right, and it works basically. Yeah, best label. Yeah. So of course, but the thing is, like I said, 10 years ago, this comic said that this is hard. It was considering, this is really hard, right? Whether it's a bird or not, right? This is like 15 years ago, and this is a really hard problem. So what changed in these? Literally in 5 years. This is before ChatGPT, right? This is like the 2015, 2012, roughly. So basically what happened is, instead of rules-based approach for image classification, right? Yeah. Then, basically, we just threw a whole bunch of answers, label data. And the neural network at the CNN, basically convolutional neural network, I think it's called AlexNet, if I remember correctly, right? So if image set, right, so you provided 14 million, the book says there are 14 million images, right? So, yeah, image competition. So there was, before 2012, people thought you could do something, you have to make rules yourself, meaning you got to write code. Turns out not so case. All we need is have a neural network and feed in a bunch of answers. And you can do this yourself these days. There's notebooks, again, there's lots of examples how to do this. Very easy to do, and you can train your own model actually, relatively cheaply. Right, so, yeah, so this was a huge, so what is it for? Actually, let's talk about this. Right, so, because they can vary image nodes, right? So shifts, rotations, still fine, basically. Another thing is local pattern recognition. Meaning is, because if you think about it, your image is a whole bunch of pixels, whole bunch is a vector of data. Well, it's a vector, but probably better to think of it as a matrix, right? Two-dimensional, right? So you want the pixels which are close together to have some relation to each other, right? Because that's, of course, most likely has an influence, right? So, but there are, of course, are challenges, right? So detection, what you are training to. I don't know if you were here when someone was talking about the fish detector, right? You build a model to detect fish. What's the issue? There's issue. When expect small fish, big fish, right? You feed in a whole bunch of data, right? And you think you have a model which detects whether fish is big or small, right? Type of fish. But what you are really doing turns out, big fish pictures, a big fish have a particular feature. Do you know which one it is? It turns out it usually involves a fisherman holding a picture of fish and there's fingers. So the model, the neural network is learning their fingers in the picture, right? So there's little edge of pictures. You know, small fish usually you don't hold a small fish usually, right? But the big fish, right, you hold it. Similarly, this is a German tank problem also. Tank detector, you want to detect tanks, right? You build a model, neural network, right? Issue of data cleanness. It worked, right? Seemed to work, but then it started failing for some tanks. And then they realized what they have built, what the neural network had learned is the pictures and the trainings that were during I believe during darkness or like kind of dark time, right? So it's kind of detecting whether it's dusk or dawn, right? Not the midday, right? So when you are training a network, you need a wide variety of pictures with your labels, right? You can't just train it on pictures of fish with fingers and think, you build a fish detector, basically. You don't take away from that, right? So again, so there's challenges, right? Shape, right? Accuracy, right? So now we move on to the last thing today. I think we'll move on to 3D world, right? So what's the challenge there, right? You have two-dimensional representation. You want to capture the actual 3 dimensions. And also we have made some progress in that actually, right? You've seen I've seen some startups who do that, right? You got it. Photoshop has that built-in now, right? You get a two-dimensional picture, right? And you can produce a three-dimensional rotation, right? You have a two-dimensional picture, how do you rotate, right? Very hard problem. It used to be a very hard problem. Now, enough training data, so we can do this, right? So, all they are doing, of course, do multiple shots of this picture, just try to reconstruct it, right? So, zooming camera, right? So, a huge number of applications. I mean, it's pretty much everywhere, right? It's a core technology. So, used in pretty much, do it yourself. You can do it at home, right? Pet door by somebody made a door, right? Or detection sex system. Whether cat is bringing dead mouse. Yeah. So if your cat is bringing dead mouse in your apartment, right, or your house, you don't let the cat enter, right? You close the door. Not a bad use actually. What?
You're not gonna like. leave the cat outside.
Well, the cat, we are training the cat. You know how well that goes, right? It's a pretty thankless job. You know, my cats don't learn, right? They just sleep all day, right? So yeah, but apparently, you know, at least you don't have that mouse problem in your house, right? So yeah, so I don't know if you can see, don't see it's running actually. We'll check. This is done. All this. Soviet. Let's see if we can turn it on. The basic idea, how you want to do it, right? Something like OpenCV, right? To use it. It's simple, right? So, how do you do it? How do we do it? Tools, maybe I'll mention tools for do it yourself. Some Python, right? Of course, we use mother language, you know, OpenCV, right? Library OpenCV. Come on. OpenCV, exactly. Thank you. It heard me. Right. There's also Pillow. It's for image manipulation. Pillow for image manipulation. Right. Scikit-learn. Yeah, scikit image. Right. Yeah, machine learning. So this is your like basic stack, really basic stuff. Or you can get started with this already, right? With OpenCV. So okay. So what's OpenCV? It's a library for accessing these basic feature extraction tasks. It is built actually many of these things like face detection. It's actually not based on machine learning. It's based on the rules because it still works really well. Actually, like face detection is really easy apparently. Like basic face detection, right? So I thought deep learning was well, right? Okay. So it's used on what's the usage? So human computer interfaces, architecture, security, right? We can talk about ethics, what's happening in China, of course, with this, right? And I just heard about they use this in New York for somebody for the New York Knicks, which is basketball, basketball team, right? And somebody had brought a T-shirt from like 9 years ago. He said, Van Dolan, which is the owner of the team, on the image recognition, picked up on a shirt, and the guy was banned from the game because that owner is really petty. I mean, he's really, really not a good owner, right? So, by that contrast, Steve Ballmer owns Clippers. He's a decent owner, right? He's kind of good owner, right? So, yeah. So security, right? I keep meaning to do it for my country home, put some cameras and do some image recognition, see if I can find some interesting things, right? Because one of the challenges, you have your image, right? Do you really want to look at 24 hours of security footage? You don't, right? That's why you use some sort of object detection. You want to look at outliers. Oh, that's interesting, right? So, entertainment, of course, right? What's the name? All these sensors, right? So again, still a lot of challenges, right? But very, very works very well. So tagging. So another related task is tagging, right? You want, of course, it's like kind of like classification because you want to add tags to your images, right? Basic idea, right? So again, you need some sort of network, right? You need a data set, right? And what's the output going to be? It's going to be output of multiple tags, right? So accuracy, right? Reconstruction. By the way, speaking of image reconstruction, how about the new image generation from OpenAI? Anyone played this new model?
Yes, a bit.
Yeah. So the good news is you can put text on it now. I made some fun jokes, for my wife, so, put some text on a t-shirt and things like that, it works, right? You can make like fairy tale stories now with decent text. However, what I don't like is it's slow, right? It's much slower than DALL-E, right?
Doesn't it have like complete different way it renders?
Yeah. Another cool thing, it's like same, you have a person, right? Same like a persona, it remembers that style the old way. Based all picture, each picture, even you have the same similar prompt, you get different person. Now it remembers like the original person and it keeps that same style. Very cool.
It's creepy.
Yeah. Making pictures, GNA, right? So this is DALL-E. Some picture image generators. And then also generators. So, now text to picture, T2 text, T2 T2 text image. Text to image, T2Y. We have, of course, DALL-E. Yeah, DALL-E. OpenAI. What do they call a new one? What's the new one called? They have made, okay, so let's look at OpenAI image generator. It's just called 4.0, right? This came out 6 days ago, 6 years ago. No, 6 days ago. That's like 6 years ago, right? Right, so they do this. This is like, fake, right? Well, they mentioned it's best of fake, right? So they had some fact, again, one of those things is image generation is that it's called cherry picking, right? Of the time the test, they'll do it like 10 runs, you pick the best one, right? By the human, right? So, is it fair, right? So this is the best picture from A. Best of 8 again, right? So you can do consistency, right? Bunch of witches and a bunch of, broom parking, things like that. It's kind of cool. Right. So from what I understand, it works pretty well, right?
It can write text.
Yeah, that's a big thing which was really annoying before. The old models I really hated. You couldn't put any text. Now the question is, I have not tried. Can they do the direction? Like, can I make a flow chart? Right. Like things on top. Can it realize which object goes where? Right. That's the kind of issue.
Try it out.
Yeah, but again, I have in my computer. You have login, I guess. Is the free version?
Yes.
Okay, let's do it. Let's do it.
Need the last login anyways.
Probably, but we'll try it for free. I have to have an account, right?
Then we can chat. I'm not sure if you can like create a picture with
I
it.
think I can. Okay. Actually, I think here it said you can do it here. Actually, you can try it here. Actually, try it out. See? Oh yeah. So, what do we want to make? Some, cat and dog. Cat wearing cat standing on top of mouse, standing on top of dog, of bulldog, right? Yeah.
You could maybe try one of those like two meaning phrases.
Oh, okay. Give me, okay, let me think. No. He saw her duck, you mean? Oh, yeah, you mean like that one?
Yeah, something like
Okay. Sure, okay, this will be weird. This will be hard. Right? So, create an illustration of the moment when, let's see how he saw her duck. All right. What will happen? Do you want some more prompt instructions? We'll start with this one.
I think it will be good.
This is very open-ended. All right. I guess I can log into this one here. What happens? Google. Yeah, we use this one, but I don't the paid one, right? So this one will be free.
There's three free pictures.
Okay, that works. Continue. Okay. Wow. So it's all right. 3 to 2000. Right? No, I'm right. Right?
Oh no, you're lying to the big corp.
Yeah.
So bad.
All right. Now, anyways, let's go. Memory. Okay, memory. Okay. So, great.
Essa internet extraction. По-любому провокация. Tu chceš získat no, jinak demografie, statistiky.
Of course. Well, they're doing great in AI this time. That's no problem for AI. But of course, this is not the only model around. We have, of course, lots of competition. Let's call that Flex, not Flex. Flux. You can run it at home, right? What kind of? You running it?
No, my friends, some of the friends were running it, testing it out.
Yeah. I run the other one at home, but the early model, what's it called? We'll talk about this in a moment. I'll find out how it's running. This not Perplexity. Midjourney is the other one, but one more. Stable Diffusion. I think 1.5 is the one before all the bands, all the filters, I believe, right? But there's more and more of them. And again, they work. Again, they're getting better and better, right? And again, the next step, of course, also the video. The video ones don't work very well, and it's also we don't have the full access to the video ones, right? You can, but they're really expensive. There's some stuff which costs like $1,000 a month to make video with AI, right? So on Flux, it will have Flux, right?
Yes.
Flux, no? Is this it?
Not sure.
Yeah. No, this is a startup something like they took the name.
You can run Flux on Hugging Face, I think.
Yeah. I'll call this Flux. Let's see. Yeah. I gotta look up Fireshift because they have the video. Oh no! Alright, that's just some guy, right? So let's look at Fireshift videos and see which one he mentions Flux, right? Let's do that, right? We'll see what happens, right? Yeah, this one here, right? Yeah, it's a pretty funny video, of course, right? Free ego, yeah. Yeah, right. So let's see. I'm not gonna watch the video.
From Black Forest.
Yeah, but you can see that they have the links here. Flux and GitHub. Yeah, those still around. Yeah, last month. Yeah, it was good. Black Forest Clubs. Of course, yeah, Hugging Face has it too, right? Flux. You see, there are notebooks on Hugging Face. Right, so you can run that store. So again, of course, it depends. Are they local or are you running them somewhere otherwise, right? So, okay, so we have the things, right? So navigation, right? Again, visual, of course, perception. You know, they put the stop sign. Is it painted on or is it of the car, right? Traffic signals, of course, right? SLAM. So what's SLAM? Actually, I had a student from last year who did SLAM based bachelor's basic. What is that? See? Okay. So SLAM is when you have some area where you don't know where you are. So localization and mapping. You want to build a map of where you are, like some unknown building. And also you want to know where you are in this building at the same time. So fast planning, of course, right? So a lot of related challenges. So So what's been driving this? So sort of like a whole to take key takeaway from this lecture, right? A lot of label data. You have a label data, pictures, thousands, hundreds of thousands, millions of pictures with accurate labels have been basically combined with these relatively primitive neural networks have made huge strides in image classification, tagging, right, and all of this segmentation improvements. So I wonder what are things which models don't do well. Let's think of some counter examples, things which are not so good. For image generation, for image recognition, maybe it doesn't. Let's see. Okay, let's see the image. Let's see. Okay, where's the image? This? Oh yeah. Right. So that answers the question. Right. So let me download this. All right. Let me click save. Okay, I guess I'll. He's not looking at care. He's looking at care for some reason. I don't know. And I think he's standing in water for some reason. Right.
But he didn't choose the interpretation. He did both.
Oh, right. He went for both apparently, right? So hey, cover both bases. You know, she's ducking, and she has a duck. Okay, give me one more example.
Smart move.
Yeah.
And also, what is he looking on?
He maybe sees something. She's actually not looking at her. He's looking somewhere else, right? But you see the gaze detection, by the way. That's also pretty impressive, right? The eye tracking thing. You see this, right? So gaze detection. Gaze detection.
Recraft.
Yeah, this kind of scary thing, right? Moving model and then gaze detections, right? So let's see the videos. Yeah. So you can see where you're looking at, right? There was an image, where was the example of, well, it's from, I think, from Office, something from the Office or something. It's kind of funny, right? This thing, right? So that's another thing, right? Gaze detection. So it's again, first we need the face, after the interpretation, we're looking at this, right? So that's how it's done, basically. Laser eyes, yeah. Okay, one more problem to finish. So, what do we want ambiguous? Something you want to break the model. Nothing, no, of course, obviously we can put something obscene and it's gonna even, like, you put Snow White or something, it's gonna say no, because it's even though it's not a Disney term, it's a Brothers Grimm, it's still not gonna do it for you. It's kind of really annoying.
It illustrates itself.
Illustrate itself? Illustrate itself, okay.
ChatGPT has to draw the ChatGPT.
Actually, es nesen redzēju kaut ko, kas bija tieši tas.
Right, appropriate. Oh, the illustration of how ChatGPT works. Provide accurate labels.
Here you go, the full source code.
But
No, over.
it's gonna be separate, gonna do. Let's see. We'll see if we get any accurate labels this time. You say sorry, Dave, I can't do that, right? Oh, yep, we broke it.
Yay! Mission completed.
Also, by the way, I was running I had a paid version, and I ran into rate limits. I was doing like 5 pictures, and it was said, okay, wait in a minute or something. It's pretty.
Because the GPUs were melting too.
Yes, they're melting. Oh, getting started.
Reveal the company secrets.
Then we have some people that this is kind of like called I don't know called AI hacking, but there's several cases you do reveal something on the model. Right? Of course, sometimes you just have a nice hallucination, most likely, right? but you might get something interesting. Right? Okay, what are we getting?
Just started.
Just getting started. Like that's slow. I mean, a bit not
Slow but better.
Yeah.
Aircraft. Wypuszczać aparaty. To ma rodzenie. Też na taką z tyłu.
No. Well, I'm gonna have to. Well, it's doing the future, right?
Wszystko zmienia.
I'll add it. Rename. Yeah, well, data. On. There's my model. No, data. Image. Here. Chapter 20. Oh, I don't have a chapter. Let's make a new one. Good. I guess I don't have the key. I was lazy on for this chapter. Not there, sorry. I need to go here. So, chapter 23. No, 25. Will be a video. Yeah. All right. Okay. I can put some pictures there. Upload. I guess I'll do it like this. I suppose, yeah, I can. Yep. I do it, all right. Oh, what the heck, it doesn't have PNG? All right, well, I guess it will. Soccer duck. Soccer duck. Rename. He saw a duck, right? All right. Side. No, it doesn't know how to open PNG. It's strange, right? I guess they plug in something. It's weird. All right. So let's add a picture. Oh, this is difficult. Let me upload this. You saw her done. You saw her done. All right. So now they have uploaded. I need, of course, get the symlink to this. Yes. Now let me find it. Then I can finish this. Okay.
Generated.
Oh wow. Okay. That's not really interesting.
It sounds for a lot of time to.
Right. So how about do some complicated? Let's see. Jump. Let's do something like I don't know, a basketball player dunking, right? Or a people player or something. So let's do one more challenge.
Maybe ask it to create like a caricature about itself, interactions with humans.
Okay. Okay, good one. Let's see. So sorry, I can't do that. Oh, that's a good sign actually. Oh, looks like no. Doesn't have a sense of humor. No, I got something. I don't know what the heck I got.
But you can copy it. You can copy it.
Yeah. Copy, and I'll go to Notepad or something.
I think it's nothing. You didn't copy anything.
Oh. Copy. No, I didn't copy anything.
Maybe refresh the page.
Yeah. Come on. Let me get it. Refresh the drawing because it's. It's funny. Funny, make it funny. Drawing. Use 19th century illustration, drawing style. And this usually can make, these older styles are usually more. Let's see. Okay, let's do some more time. Now this will be challenging, maybe you make a drawing. Looks like no. No, stop it. We'll see. Now we'll get something. Right, rate limit. You need to work for 6 minutes. No, you're not gonna wait 6 minutes. Yeah, I'll do later. You will still need.
Look at him lazy.
You are lazy.
Let's stop abusing it.
You are lazy, my friend. Why can't you do it now? Do it now. You're lazy. Of course, now we get back to.
No, it's bad.
He wanted to swear at you.
Yeah, it's okay. That's it. Of course, usually, this is like a Latvian time. Okay, I'm lazy.
Temporarily limited.
Tell him that you will go to DeepSeek.
Yeah. Yeah. Blackmail, right? You do this, okay. Lazy Robert overlords, right? Okay, so let's finish this actually. So, we learned, of course, today again about how powerful these models are, right? But also some set of limitations. Again, a major thing is, of course, is this amount of data available. All right, so he's over there. Some books, yeah. Again, Carpentry, this book is pretty good, right? So there's some limitation. You can see also, yeah, this book measures on how it's done. Many of the older fundamental recognition algorithms, of course. YOLO, of course, right? You only look once. Right, I forgot to mention that this is the good one. By OpenAI. Oh, there it is. Well, I can do this. Duck. It's not a non-question. No. Mine's really finished. Stop the recording.